of background on Zite. We're really a two-part business. We are both a software business, as you see at the bottom on the left, and a services business. Why? Well, for organizations who need web data and who have web scraping engineers, we provide software. So we provide solutions for bans, for extraction, for hosting spiders, solutions for those teams of engineers. For organizations who need data and who do not have teams of web scraping engineers, we provide that as a service. So we have our own large team of web scraping engineers. And so we provide data to organizations who have need of it, and they use our own software tools. And so in that regard, we eat our own dog food. We are the first user of our own solutions. But this means that we have several audiences, several groups of people that we talk to. But something that is common across the engineers who use our software, both the customers of our software and our own engineers, the customers of our services, is we hear a theme that web scraping is difficult to scale quickly. And what does that conversation typically look like? Normally looks something like this. So let's imagine what we've got here is an organization that's doing something like price monitoring, very typical use case for web scraping. They've got a new opportunity to expand into Asia. And so that they've got a data need associated with that opportunity. They may be saying, for us to open up this business line in Asia, we now need to be scraping 200 e-commerce sites in that region. And so a commercial leader, a consumer of that data, will then approach their data team lead and say, okay, we've got a goal for the next quarter. We need to add 200 more sites. And that data team lead is often saying, that's hard. So there's a setup challenge. So depending upon the complexity of the site, that might take a day to resolve the bans, to create a spider that crawls the site, that turns HTML into structured data. It might take 3 days. But these teams are typically not sitting on their hands waiting for work. Quite often, a large part of their capacity is already consumed maintaining the sites that they are already running. It's a maintenance challenge there. And so in terms of the challenge to scale, we can describe it really in two parts. The first is the cat and mouse problem with bans. So we hear from the people we work with that solving bans using traditional methods is a horrible process. Very opaque, typically requiring, depending upon the complexity of the anti-bot, multiple proxy types, data center proxies, residential, maybe mobile residential, technologies like headless browsers, maybe browser farms for multiple browser configs to address fingerprinting issues, configuring these solutions together, having multiple subscriptions, so a certain number of gigabytes of residential, a certain number of requests of data center proxy solutions, and then finding the leanest successful request, well, the leanest successful configuration, I'm sorry. And that leanest point is really important because solving bans would not be that challenging if we could throw everything at mobile residential and browser rendering, if we could tolerate paying $20,000 per million. But most of us can't tolerate that. We have to find the leanest successful configuration that we can. And that is a challenging activity. And it becomes more challenging when there are ongoing changes to that site's configuration. When rules are changed, and then we're back to square one. We're trying to find that config again. And during that gap, we may be losing data. So this is a challenging process. The one on the right is around spiders. So, okay, we've resolved the ban. We've got the HTML in the format that we need. We now need to turn that HTML into structured data. So we're writing spiders to crawl a site, to find the structure of it, to find the right crawling strategy, to turn that page of HTML into structured data that we can output in JSON or into a database. Again, there's that setup cost, and then there's a maintenance problem. And between these two challenges, these are the issues that are facing or that are challenging the ability for us to scale quickly using traditional methods to add many, many more sites quickly. And so for these kind of goals, in order to scale faster, we need a different way of working. And the opportunity that we see is the speed and scale of AI, but particularly with complete control. And this is really important. I can't expect anyone on this call today to make use of an automated solution If we cannot make that solution, give us exactly what we need. And that's what we're going to look at today. But before we go into the detail of that, let's start with a fairly lightweight demo. Let's look at something. Fernando, would you like to take over?
I'll take it over. Yeah. So for this one, we're going to be looking at a scenario, a very simple scenario of how can we, apply AI and AI spiders to a real world scenario, to a real world problem. Let me share it. Uh, Everything okay? Is it sharing? All right.
Mhm.
So say that I am one such data lead that has received that request of, adding more data to a specific project. And that project would be crawling games that are on sale on, many different sites. One such sites could be this eStarland site here, where you have a specific tab here for daily steals. Daily steals are basically, sale items on sale, etc., that are discounted and tagged by the editor team, by the website, and you can see them in here. So thinking about a product, a really gigantic product that would crawl like multiple websites like this, it is going to be really hard for me as a data lead to, scale up and create spiders for everything. So I've heard that Zite has such a way of creating those spiders, without much code, without much problem, without maintenance. And so here I am at the homepage of Zite. You would sign in, you would be looking at your own homepage, and you would create a project. So let's see, a project demo, a so what I'm looking to deploy here, I am looking to deploy Zite AI powered spiders. So using the no code solution for web scraping. So I would select that and also need the required subscriptions for Scrappy Cloud, since we are running things through Scrappy Cloud, and Zite API, which is the main driver where we are sending the requests for the sites to be crawled. So let's create a project, pretty simple, pretty fast. And the first page, you will be greeted by the templates. So right now we have the e-commerce template. There are more templates coming, and there are ways to add on or your own template. This is something that we're going to go in after the second part of the demo. So for this one, we're going to look at this template here, ready-made template for anything e-commerce related. So selecting this, you will have a pretty standard way to define a spider. Right now, we're looking at the star. The URL is the URL with the exact place where we want to look at the results. Geolocation, since this is a website based on the United Kingdom, I believe, or I believe America, let's try out United Kingdom here. Let's not limit the requests too much. 100 requests is good. You can limit the amount of requests that you're making. Just not to spend too much on your testing, on your revenue crawling. So you would have 100 Zite API requests, which would be reasonably cheap. And you would also need to define the extraction source. So there are two ways to extract things from a website here. You would use either the non-rendered approach or the rendered approach. So without rendering, you wouldn't have JavaScript rendered information inside the page. But this is not an issue for most of the websites that you're crawling. You can get the information that you want without rendering for most of the time. For the times that you don't, you would choose browser HTML, which uses browser rendering. And for the crawl strategy, you would go, okay, let's crawl the entire website. Let's go for everything that is in that page that we just added here as the root. We're gonna go comb the website. We're only gonna navigate a little bit, categories. We're not gonna go deep, or we're just gonna follow pagination. In this case, we're gonna only follow pagination because we're not interested in the other categories. So with that said, we can just save and run it. And the spider is done. Basically, it is already running, and we can have items in a couple of minutes, in a couple of seconds right here.
So that's going to be running for a few moments. Fernando described what we're seeing here is a product template, but it's also a product machine learning model in the background. And that has a schema of around 20 data points. And they're the kind of data points you'd expect for product style data. So product titles, prices, tax, in-stock status, and so on. And so as we see data in a moment, we'll see that schema. Fernando also touched on that we're adding further data types. So we're in late stage testing on articles. That's coming up very soon. We're going to be adding jobs shortly after that. We're working on search engine results pages. And so you'll see that that first screen where we saw products, you'll see that growing over time as we add more data types where there's a template associated with a machine learning model for that type.
All right. The job is still running here, but we can already see items. So for instance, here are one of the items that we just crawled with a lot of additional properties, so price, MSRP, release date, rating, the name of the actual game, the platform, the publisher, the review count, if it is available, if it's not available, the description of such an item, and the HTML directly related to this description, the GTIN, which would be very important for the duplication later on. You would have the price and the regular price, which is separated because this is a sale. This is a sale product. This is on sale, and the SKU of this specific product. So you can see here, pretty much we have a lot of items already, and I've done no coding now.
Great. We'll come back and we'll see a deeper view shortly where Fernando takes more control over that crawl. Should I share screen again, Fernando?
Go ahead.
You just unshare, please.
Oh.
I think I've got that wrong. 1 second. Are you seeing the slides?
Started screen sharing.
Not yet.
Sorry, I'm having trouble getting this to come through. I think I need to stop the slideshow and then restart it. Better this time?
Yes.
Sorry about that. So that was a quick view. Let's have a little look at what's under the hood. And I'll take you through 3 steps on this. Through how it's approaching bands and retrieving HTML, how we are turning that HTML into data, and how control can be taken of this process. And we'll see more of that in a second demo. If I start with the bands, and so at the top of this conversation, we were talking about solving bands as a process and the challenging nature of it, how it can be very opaque, of often using multiple technologies, multiple subscriptions, trying to find the leanest configuration across those solutions. Zite API automates that. It's got libraries of strategies under the hood. It's got all of these technologies under the hood. And so it automates the finding of the leanest successful configuration that works for that site. And so in doing so, it eliminates that cat and mouse problem. And how successful is that? It's very successful. Towards the end of last year, we were bench tested by the review organization Proxyway, and they measured us against the offerings in the market, the competitors for these band solving solutions, web scraping solutions. And Zite API came out strongest on success rate by a considerable degree, but also fastest by a considerable degree. And so it's a great solution for scale, but it's also the most cost effective. So what you're seeing here is 5 tiers of sites. And in the middle, that color coding there is the use of technologies to solve those sites. So the sites that have the simplest anti-bot technologies, which we call tier 1, these are the sites that are typically solvable using just data center proxies. You'll see from the website distribution, that's the largest group of sites. And most of the sites that you'll be scraping are in tier 1. They're the cheapest band. But why do we use these bandings? It's really because we want to make sure this is the most cost-effective solution you have. it's fully automated and it takes that painful process away. But we know that people cannot justify that if there's a cost trade-off. If this is a lot more expensive than the manual methods, and it isn't, because we take this approach. For a site that's relatively simple, that only needs largely data center proxies, that's all you're paying for. And so it's cost competitive with doing things the manual way. And so you get that benefit of automation, but without a cost penalty. There's also just a single subscription. You don't need to worry about how many gigabytes of residential you need. It's just one subscription and it just works. And in doing so, it eliminates that cat and mouse problem with bands. You can just delegate the problem to this solution. But let's look at extraction. So how is extraction working? We've spoken a little bit about machine learning models. This is a dedicated machine learning model created specifically for web scraping and specifically for each category of sites, of products and so on, articles and jobs. We saw it gives instant setup. So Fernando put in a URL, he picked a few parameters, he hit go, within 60 seconds we were seeing data appearing. But also it's addressing maintenance. And why? So by using a dedicated machine learning model, this is vastly cheaper than a large language model. The cost is around 1/50th the cost of ChatGPT 3.5. And people who are using large language models for web scraping, because of their significant cost, are typically using them to generate static code, which then runs at runtime. But the challenge of that approach is when a site layout changes, that code needs to be regenerated and retested. Because these models are dedicated and they're so much cheaper, it's economically viable that they run on every page, and therefore the solution is self-healing. Even if a site layout changed during the middle of a long crawl, the solution keeps step with that because it's applying the model on every page. And in doing so, it's addressing maintenance. And so through this approach, it's facing that challenge of setup head on, and it's facing that challenge of maintenance head on. But let me talk a little bit more about types of AI. This solution will have both supervised machine learning and large language models within it. Right now, the core of the solution is supervised machine learning. We're in the process of adding large language models. And why? Because that allows getting the best out of both. Dedicated models we find are more accurate, they're faster, and they're cheaper within the scenarios where the data is within the structure of the page. And that is the majority of cases in web scraping. So this is where the price is in a div and the title is in a div. And so with that structured approach, the machine learning model can find those data points very cleanly and with a very lean model. It's very strong for well-standardized data types like products and articles and jobs and so on. Large language models have unmatched flexibility. So I spoke earlier about our own professional services team. They've been adding large language models to this solution in order to address use cases like, for example, capturing data points out of long description text. So we saw that in Fernando's crawl. We saw a block of HTML for description. And so we see use cases where people need to lift product dimensions, for example, out of a long block of text. And large language models are superb for flexibility for that. Or for quickly adding further data points to schemas that a specific site has beyond a standard schema. And so in the combination of these two, we get that accuracy, that speed, that very low cost base of the supervised machine learning, but we're adding the option of large language models for the unmatched flexibility. Now let's talk about control. So we saw Fernando take a UI, enter a few parameters and hit go. In the background, that was running a Scrapy spider, a Python spider, relatively simple one. And that spider in turn was calling Zite API to solve bans and conduct machine learning extraction. But as well as picking that up and adding parameters and hitting go and running, it's open source. So you can take a copy of that, you can fork it, you can edit it, and in doing so, take complete control over that crawl. So you can adjust the crawling strategy, add filters, add further data points if a given site has data points that are not part of a standard schema. And so doing so, you can have complete control, and to do so in familiar technologies. For those folks on the call today who are Python engineers, you'll find this incredibly familiar. It's very familiar technologies. But Fernando, take us through it.
Perfect. Let me share my screen here and we go to the second part of the demo. Right? See? Okay, so yeah, as Ian was saying, basically everything that we're doing right here is open source. We are using open source repos to pretty much disseminate the usage of templates, to disseminate the usage of everything that you was related to, scrapping and etc. So for this one, for this specific part, we have a couple of documentation pages around this. This is the pretty much the one that uh, explains how to create those templates. I'll drop the links in the description and the chat later. And I believe there is going to be something in the Discord later. I can add it there. So basically, there are two main repos that you want to be looking at if you're looking for customization. The first one is Zyte Spider templates. This is where the templates live, the code that is running, that was just running that spider that we just queried. You can see the actual code here in Zyte Spider templates, spiders, and e-commerce. And this is basically the code that was running back there to get that information without me actually going through and coding everything here. Um, the second one is the Zite Spider Templates project. So this one is basically a framework, not framework, but a template for you to use in your own project to just get out of the box access to those templates. And so if you go here and you run everything that is here for first steps, the usage of the spider, you will end up with a scrapey project ready to work with a custom template. That custom template, I've actually made one for myself here, and I've just forked that repo and added one single file to everything there was there, which was this custom template.py. So this is pretty simple. We're gonna only change two things. One is gonna be the parameters that we're gonna be ingesting from the UI. So, all those parameters that we added, like the max requests, if it is going to use browser rendering or not rendering, we can add in more to the UI so that a technical person can help a non-technical person to achieve something different with the spider at runtime. So for this one, we're adding three things. We're adding a max price parameter. So, I don't want to crawl anything that is more than $30. Min probability, which is I don't want anything that the model says that it's 99%, it's not 99% sure that is an item, that is a product. We have the probabilities from the model to say that if that item is actually valid or not. And we could add something like brand. We could add a filtering inside the process itself, so we can just change the behavior of the spider on the go. And the second one is the actual template that we're going to use. This template takes in the e-commerce spider, which is inside that package that we just talked about, the spider templates. And we're going to take in the custom parameters that we just added, that take in from the e-commerce spider parameters, adding a name to it, adding a couple of metadata tidbits to it so we can see this in the UI, so custom e-commerce filters and stuff. And the most important thing here is the actual parse product uh, function. So in the template, the parse product function is the one that's going to take in the page, the product page, and is going to yield the product. This way, we can actually capture before this product goes back to the pipeline and is yielded. We can get the response and the product, and we can actually just crawl as we usually do in Scrappy and add in more things to the item. So in this case, we're adding three new things, which is a price filter, a probability filter, and a brand filter that are gonna all act in the characteristics of the product, of the item that we're getting. So if the price is smaller than the price that we're just setting, if it is bigger than the probability that we're given, if it is actually, the brand, if the product is the brand that we're looking for. And we can even do things like modifying the items, modifying the actual fields with response data. So we can get the URL, for instance, or we can just add in a selector and get information from the data and inside the item here. And if everything is okay, we use the product. So after deploying this, so we had a deployment running here in the background. After deploying this, we can go back and look at the dashboard and try to create a new spider. So creating a new spider, we're gonna see the new template here: custom commerce, price probability, brand filters. This is the one that I just added. We can select it, and it's pretty much the same with the max price, min probability, and brand filters. Okay, so let's go get the website here. The start and filter. URL, geolocation same, GB, max requests, HTTP response body. We're gonna go follow pagination only. Let's say we're only looking at items that are less than $30, or maybe $20. That would be small. And let's save it and run. And it's done. It's basically we are running what we just customized, and it's now just waiting for items.
So we'll see that in a moment or two. What I think is quite nice about the process that we're seeing here is we saw Fernando take a fork of that spider, edit that spider, including adding parameters that could then be set via the UI. And that's quite nice for a separation of roles. So we can imagine here now that once Fernando has created that copy and modified it, then a non-engineer can just run it at any time. Perhaps a tester or a business analyst, say, could come in, add the properties in the field, hit go, and so they don't need to be an engineer to do that.
All right. So we're already having a couple of items here. It is stopping, and there's less items than we just saw for the. Oh, sorry about that. Let's get to the dashboard. So I've ran a couple of other jobs. This is the unfiltered one. So we would have 47 items, just like 47 items appear here at the actual page. We get the number that we're expecting. For the filtered one, I've ran two. I've ran another one here, but we just run this one. This is the Starling filter with only items that that check the mark that I just added for the price. So there is no items here with a price that is smaller, that is higher than 30 than $20. So yeah, that's pretty much it.
Right. You don't share, I'll take over again.
Yeah.
So as a way of working, what we're proposing here, and this is the way of working that we're now using in our own professional services team with our own data customers, is to let the AI do what is common. That for a data type like product or articles or jobs, where our schema's got 20 odd data points, it can do all of this out of the box. And in order that you can focus your time on what is specific to your own use case, or maybe specific to an individual site, specific to the goal of your own organization. And in doing so, you can get a lot more done. And again, this is the experience that we're having. We eat our own dog food. And so where we are using these technologies with our own customers, we're able to get started very quickly and focus our time on that last mile, on the bit that's specific to that scenario. In particular, we're finding this very valuable for adding new sites quickly. And our own customers are finding this very valuable where they want to experiment. So maybe they want to try things out, try out new sites where it's not yet known how much demand for that site there is or for the data from that site. And so this is a wonderful way of scaling quickly and getting to data quickly for that kind of scaling. But please don't take our word for it. We'd like to share a discount code with you today, which will give you $10 of credit. Please give it a go. Tell us what you think. We've touched on that we're adding further data models, articles, jobs, search engines, search engine results pages. We'll be adding more. We'll be adding more features for further crawling strategies. But we'd love to hear from you. And in particular, a place where we'd love to hear from you is on Discord. So Clever, please do paste that link into the chat where people can pick it up, as well as the link to where people can register for a trial and use that code. So please join us on Discord. We'd love to have you as part of our community. We'd love to hear from you and gain your ideas and your reflections and your feedback. I'd like to share another talk that we've got coming up next week. This is from Neha. So Neha's talk is going to be a bit more hands-on. We've had a demo today where we've seen quick use, instant setup, how to get to data within a minute. We've seen the principles of how to configure the solution to get exactly what you need. But Neha's going to stress test that next week. So we're going to stress test her, perhaps. We're going to ask her to build 30 spiders in 30 minutes. So the clock is going to be ticking on Neha's workshop. So please, if you have found interesting what you've seen today, I'd really recommend that you join that call with Neha next week. But Clever, please come and say hi and talk us through the questions that we have today, or the reflections that we have today.
Yeah, sure. So we had the first question here. AI is a general term. What type of model are you using? LLMs? What vendor do you use?
I'm glad you asked. So I suspect that we touched on that after you raised the question, but the core of the solution is supervised machine learning. And as we touched upon, the reason why we're taking that approach is for scenarios where the data is in the structure of the page, where the price is in a div and the product name is in the div. We find that a much more effective approach. It's more accurate, it's faster, and it's cheaper, it's leaner. We do make use of large language models where the benefit of its flexibility wins. So where we need to get data points out of unstructured text, or where we quickly need to want to add data points that aren't in the standard schema. That's an alternative way of doing it, other than what we saw from Fernando, where you can add further data points by adding them to the spider. So we believe in a best of both approach, but the core of the solution is using supervised machine learning.
All right. Next question, is there any optimization for scraping duplicates?
Fernando, are you able to speak to that?
I can take that. So very quickly, I'm gonna give you two ways of doing this. The first one would be the default way, with the scrappy engine is working. It is gonna deduplicate on the fly the URLs that you're taking in. You can change the duplication filter to use whatever you're thinking about. So for instance, I wanna get all the items from previous jobs. I want to get all the URLs from previous jobs. I can take that inside the spider and just ignore anything that we just called. The second way to do this would be to add in another layer of complexity, which would be, for instance, adding a collection inside Scrappy Cloud that would just be looking at the URLs that you just crawled and just sending a message to saying, okay, do we have this already crawled? If we don't, then don't crawl, then don't go ahead. It is something that you would need to add into your project. I don't think we have any specific optimizations for this.
All right. Next one is, when will we have the search engine results page, jobs, and other data types available?
I'm sorry, I don't have a date yet, but it's high on our list. The next one that we'll have in the solution is articles. But we are actively working on search engine results pages right now. As soon as we have a forecast date, I can provide that.
All right. Another question is it possible to keep the proxy static for a couple of requests or seconds?
I can take this one. Basically, there is a sessions solution coming into Zite API in a couple of weeks, I believe. That is pretty much that. You're gonna send in to create a session. You're gonna use the same proxy. You're gonna be using the same framework for a couple of requests, and then you can just use that. I think you can pin the proxy in there. I might be wrong with that. It should be enough for your use case.
Nice. Next question, how good is your solution on sites that are actively trying to block scraping using systems like Cloudflare, etc.?
It's specifically designed for that. So Clever, if you have a moment, could you find a link to the Proxyway review? If not, I can find it.
Yes.
So I mentioned during the deck that we were bench tested against all of the solutions on the market of this type of APIs that are designed for web scraping, either just for unblocking or for extraction as well. And we were tested against a full variety of anti-bot solutions, including Datadome, Cloudflare, Akamai, the big names. And Zite API universally came out on top of all of them. So, but please, you don't need to take my word for it. If you search for proxyway unblocking APIs, you'll find that review. And it gives, as part of that review, it gives a full description of the range of sites, and they were specifically chosen to present a range of anti-bot tools. And you'll see that in there, and you'll see that Zite API was very successful against all of them.
Right. How did you evaluate your machine learning model? Any metrics you can share? I think we spoke about it.
I don't think we specifically covered it. It's the machine learning models have actually been in development for some time. They've been undergoing continuous optimization, and it's a typical machine learning workflow of training data and test data. It was previously a separate product, what we called automatic extract, and we brought that into Zite API towards the end of last year. We've since over the last year, we've continued to increase its accuracy, but in particular to allow it to run on unrendered HTML. And that makes it significantly more cost effective. So running on raw HTML, unrendered HTML, it's really good value. It makes complete economic sense. It's something you can use on any site. As I described earlier, it runs on every page, and that's what makes it self-healing. So that's been an ongoing process of development and optimization. What's been more recent is for us to combine that within Zite API with a solution that solves bans, and to provide it within this structure of an open source template that you can then take and edit. So that open source template you can take and edit for complete control over the AI is something we've just released. But actually, the machine learning models have been in development and optimization for some time, and that's why they're very mature.
All right. I'm going to share here in the chat a link to a recent blog post we published regarding LLMs and our AI for web scraping. Another question.
Sorry, I'll just touch on that briefly. I described how we are integrating. You'll be able to call large language models as part of the solution around the summertime this year. And as I described, that's for use cases such as the ability to get data points out of unstructured text, like a description field. But coming back to the previous question around training models, we're increasingly using large language models as part of our training workflow for our supervised machine learning. So one of the ways in which we drive up quality is we have a hinting process. So our models are trained to work on whole categories of sites, like all product sites. But then we capture hints for individual sites in order to ensure that each individual site has a very high standard of quality. And large language models are increasingly part of that process. So again, we can kind of get a best of both. We find large language models at their best at design time, effectively, when they're not running on every page. We can get their power and their flexibility, and then they can capture data which we use at runtime leanly and effectively.
All right, a couple more questions before we finish. So this one is probably about customizing the templates. Can you add a parameter that limits the items by the date they were published? So it only scrapes items that are published before certain date?
Yeah, no. Basically, you can anything that you can see on the page, you can use as a parameter and alter the item that you're getting from the template. So in my case, I've altered the SKU field, the SKU field, but you could just as well use the published date, the date published. You can get that information from outside the template. Maybe the AI didn't catch that at a first glance. So you can use that and just filter your crawls using that. Yeah.
Right. How do you work out the price for a crawl?
We have a price calculator. The simple answer is you don't have to. So we've got a tool for that. So if you go onto we'll provide you a link to sign up and take a trial. In there, you'll find something called a cost estimator. If you put in a site, set a volume, and then you can pick features like, do I just want to solve the ban? Do I want to extract data? And if you pick those two, you'll see the cost of a crawl.
All right. Is supervised machine learning inherently unpredictable? While it's true that AI adapts to website changes, how can we ensure machine learning behaves as expected?
I can have a go at that. Fernando, do you have an answer on that one?
Basically, you have already answered a part of it, Ian. Basically, what we can do to reduce those kinds of errors is actually using your own hinting for specific websites. So, for instance, there is a large e-commerce that we want to crawl and everyone's crawling it. We're gonna add in hinting for that to increase the accuracy for that specific one.
All right. Last one is, could we create our own custom LLM and machine learning models to work with the spiders? If so, is there documentation to show how this can be done and integrated with Scrapy?
I don't believe we've documented it. I assume you're thinking about like a lang chain approach or something like that. I know that our developer experience team are working in that space. I don't believe we have yet documented that, but we'll take that one as a takeaway. So thank you. If we've got your name, we can get back to you, or that's perhaps something we can share in the Discord community because that's a great one to raise.
Yeah.
Fernando, do you have anything to add on that one?
No, nothing to add there. I don't think I don't remember if we have any public repos regarding LLM training. But this is a good question.
No, it's a good one.
Yeah, we can continue all the conversations and the questions in the Discord community. But for now, it's about time for us to finish.
Well, thank you very much. There's been some really good questions today. Thank you all for joining us and for raising those really good questions. But as we touched upon, we'd love to see more of you on Discord to get your honest feedback, to hear your thoughts on where we should take this next. But thank you. We'll share the recording of from today from those who are on the call, so you can go back and reference that. But thank you. Let's all talk again soon.
Thanks, August.
Thank you, everyone.